Have you ever wondered what it takes to build something that's truly impossible? Well, today, we're going to do just that. We are going to architect a massive national-scale application from the ground up, one where failure just isn't an option. So let's peel back the layers and look at the blueprints for a system designed to be completely unbreakable. All right, let's dive right in. I want you to put yourself in the shoes of the lead architect here. Your job? Build an app for an entire country. And we're not talking about just any app. This is a critical piece of digital infrastructure, something people are going to rely on every single day. The stakes? They couldn't be higher. So first up, let's talk about scale. This is not your average app. We need to handle over 10 million users, and the traffic could spike at any moment without warning. It has to work just as perfectly for 10 people as it does for 10 million people using it at the exact same time. And here's the reliability target, our big goal. We're aiming for 99.99% availability. In the industry, we call that 4 nines. So what does that actually mean in the real world? It means we have an error budget of just over 4 minutes of total downtime per month. That's it. Any more than that, and we failed. Oh, and to make things just a little bit trickier, there's a huge constraint. We're dealing with very strict data residency laws. This means every single byte of user data has to be stored and processed on servers that are physically inside the country's borders. There are absolutely no exceptions. Okay, so with all those intense requirements, where do you even start? Well, the first decision, and honestly the most important one, is picking the right architectural blueprint. This single choice is going to shape everything that comes after. We've basically got 2 main paths we can go down. The traditional way is to build a monolith, where the whole app is one giant interconnected program. You can think of it like a big ball of yarn. You pull on one thread, and the whole thing gets tangled. Or we can go with a more modern microservices approach. This is where we break the app into lots of small, independent services, kind of like Lego blocks, where each piece does one job really, really well. For our unbreakable app, we're definitely going with microservices, but we're adding a special twist. We're making it event-driven. So instead of services talking directly to each other, they just publish events, like little memos about things that have happened. This is awesome because it decouples them. A service doesn't need to know if the payment service is online right this second. It just shouts, "Hey, an order was placed," into the system, and the payment service can pick it up and process it whenever it's ready.
All right, we've got our blueprint. Now let's talk about building our defenses. How do we actually make this thing bulletproof and hit that crazy 4 nines uptime goal, even if disaster strikes?
I really like this slide because it breaks our defense plan into 2 different layers. First, you've got high availability, or HA. That's for surviving the small stuff inside one data center, like a server going down. Then you have disaster recovery, or DR. That's the big plan for when something catastrophic happens, like an entire data center gets knocked offline. And the way we do this is with what's called an active-passive multi-region strategy. It sounds complicated, but it's pretty simple. All of our live traffic goes to our primary active data center. But at the same time, hundreds of kilometers away, in a totally different city, we have a passive data center that's an exact mirror, constantly getting copies of all the data. If that active site ever goes dark, we just flip a switch, and all the traffic gets rerouted to the standby in a matter of minutes. Now, with millions of users, you're going to have a flood of data. And that data needs to be written securely, it needs to be read back instantly, and, this is a big one, we need a perfect, unchangeable record of every single transaction for audits and compliance. The absolute key insight to solving this problem is to stop thinking about your database as just one thing. We're going to completely separate the system that handles writing new data from the system that's responsible for showing that data to our users. And this flow shows exactly how it works, using a pattern called CQRS. So a user action, like submitting an application, is called a command. The system checks it and then creates an event, which is just a statement of fact, like application submitted at this time. That event gets saved forever in a log that can't be changed. That is our ultimate source of truth. Then that same event is used to update a totally separate database that's designed for one thing and one thing only, being read super, super fast by the app's interface. So this technique of using that log of events as our main source of truth has a name. It's called event sourcing. And because that log can never, ever be changed, you can only add new events to it, it gives us this perfect forensic level audit trail of every single thing that's ever happened in the system. And for any industry with regulations, that's not just a nice to have, it's an absolute must. Okay, let's take a breath.
We've got our core patterns, event-driven microservices, a multi-region setup for uptime, and this cool CQRS pattern for our data. Now it's time to put all of these powerful pieces together into one secure, well-oiled machine. There are really three key layers that make this whole thing work. Right at the front door, we have an API gateway. Think of it like a bouncer at a club, checking every single request before it gets in. Then, deep inside, we have something like Kubernetes, which is like the conductor of an orchestra, making sure our dozens of little microservices are all running and playing in harmony. And then, connecting them all is a service mesh, which creates a private, secure, encrypted network for them to talk to each other. It enforces a zero-trust policy, which basically means trust nothing, verify everything. So, let's do a quick recap. You can really see here how each of our big architectural choices directly solves one of our main problems. We use the API gateway for security, we use that active-passive multi-region setup to survive a total disaster, and we use CQRS and event sourcing to get that perfect mix of high speed and rock-solid data integrity. See, it all fits together.
You know, if you only remember three things from all of this, I want it to be these core principles. Number one, decouple your services so that a failure in one small part doesn't bring the whole system down. Number two, replicate your data in different physical places so you can survive a catastrophe. And number three, automate absolutely everything you can, right from day one. So there you have it. We've just designed a really powerful, really resilient system using the best tools and patterns we have available today. But, you know, technology never, ever stands still, which leaves us with one final big question to think about. What comes next? What new technologies, what new patterns are on the horizon that will help us build the truly unbreakable applications of the future?